Today we are doing the determination of wavelength of light by Newton's ring method. Here we have a sodium lamp as source. G is a glass plate kept at 45-degree angle with the incident rays so that the rays fall normally on the setup. The setup is a plano-convex lens and a plain glass plate, and an air film is formed between this plano-convex lens and the glass plate. The rays get reflected from the two surfaces, the upper and lower surfaces of the wedge-shaped air film, and then they interfere to form a interference pattern, which we can see through this traveling microscope. Now the interference pattern looks like this. So this is a ring type of pattern, and we get concentric rings with a dark center because the rings are being formed by reflected rays. So this is the working formula where lambda is dm square minus dn square by 4 rm minus n. dm and dn are the diameters of mth and nth order bright rings, and r being the radius of curvature of the plano-convex lens which will be supplied. So this is the experimental setup in our lab, where you can see that this is the sodium lamp source and this is the glass plate which was referred as G, and here we have the setup which is made up of plano-convex lens and the glass plate, and this is the microscope through which we can see the rings. Now this microscope has two scales. One you can see here, this is the linear scale, and another one which is attached with it is called the circular scale. So the light gets reflected by this glass plate first, then falls on this one, and then gets reflected back again and interfere. So this is the linear scale as we were talking, and you can see the pointer here. The pointer marks the main scale reading. Here one smallest main scale division is 1 millimeter, and this is the circular scale which consists of 100 divisions in the circular scale. And from the first table we have to calculate the screw pitch first of this circular scale, then we have to find out the least count. It can be seen that for one complete rotation of this circular scale, the pointer moves by 1 millimeter in the linear scale. So you can find out the screw pitch from here, and then the least count by dividing the screw pitch by the total number of divisions in the circular scales, which is 100. Now this is the pattern which we get in the Newton's ring experiment, and we can see it through the traveling microscope. You can see the cross wires here, and we have kept it at the center first. So for a test reading, let us check the first reading. So here the reading for the main scale will be the reading which the pointer has already crossed. So we can see here that it has crossed the 43 mark. So 43 mm will be the main scale or linear scale reading, and the circular scale reading, the method is same. The pointer here has crossed the 47th line, so 47 will be the circular scale reading. So this was just a test reading. So we will have to move the circular scale counterclockwise to take it from center to extreme right and make the cross wire parallel. The vertical cross wire should be parallel to the 15th dark ring, dark or bright, whatever you can take. So we have taken here the bright ring. So the cross wire is parallel to the 15th bright ring, and it is on the extreme right end, and we will now move from right to left. So what will be the readings for the 15th ring on the right side? So this is the main scale reading. We can see that the main scale reading has definitely crossed 40, but I'm not sure whether it has crossed 41. For that I need to check the circular scale reading. And in the circular scale reading I can see that the reading is 97. So I'm sure now that the pointer has not crossed the 41st line. So the main scale reading will be 40 and circular scale reading will be 97 for the 15th ring on the right. Now we will move the screw clockwise and we will move from right to left, and by doing so I have kept the cross wire on the edge of the 12th ring. So on the edge of 12th bright ring. So let us see the linear scale reading is now 41 and the circular scale reading is 39. Now we will do the same thing and move the crosswire to the 6th ring where the linear scale reading is 41 and circular scale reading is 61. Moving the screw in the same way, we move it to the 3rd ring. So the right side of the 3rd ring, and the reading is, in the linear scale it is 41, in the circular scale it is 86. Now we move it in the same way and take it back to the center, and we keep on moving in the same direction and put it on the left of the 3rd ring. So the crosswire is now on the edge of the 3rd bright ring on the left side, and the reading is 45 in the linear scale and 62 in the circular scale. In the same way we move it to the edge of the 6th ring, and the linear scale is 45 and the circular scale is 90. We move in the same direction and reach at the edge of the 9th ring. So the left side reading for the 9th ring is linear scale 46 and circular scale 07. Now we move it in the same direction and go to the edge of 12th ring on the left, and the reading is main scale 46 and circular scale 27. Again we move in the same direction and reach the extreme left side of the 15th ring where the reading is 46 in the main scale and 50 in the circular scale. So this reading is the reading of the 15th ring on the extreme left. So in the next chart we will start from right here and move the circular scale counterclockwise now. So we will move it from left to right, that is in the opposite direction. So the reading for 15th ring will be same. So moving in the opposite direction we will reach to the left of 12th ring again, and the reading for the 12th ring will be 46 in the linear scale and 34 in the circular scale. Now we move it in the same direction, that is counterclockwise direction, and move the vertical line to the 9th ring, and the reading now is 46 on the linear scale and 15 on the circular scale. So again we will do the same process and move along the same direction. For the 6th ring the readings will be 45 on the linear scale and it is 87 on the circular scale. For the third rings left, we have the readings as 45 in the linear scale and 57 in the circular scale. So we will keep on moving it and we will reach the center. After that, we will reach the right side of the third ring and the reading will be, this should be 41 and the circular scale is 86. We keep on moving and go to the sixth ring. The linear scale is 41 now and the circular scale is 54. Next we move on to the ninth ring, the extreme right of the ninth ring, and the readings for the ninth ring are 41 millimeter in the linear scale and it is 35 division on the circular scale. We keep on moving and move to the 12th rings right and the reading is 41 in the linear scale and it is 16 on the circular scale. Again we keep on moving and move to the position from where we had started earlier, that is the extreme right of the 15th ring. So let me see the readings. So again I am having a confusion whether it has crossed the 41 or it is 40. So let us check the circular scale. So it is 94. So the linear scale will be 40 and the circular scale will be 94. So now we have all the data to fill up this table, and from this table you will find out the diameters of various rings, that is 3rd, 6th, 9th, 12th and 15th rings. And when you find the diameter, find out the squares of the diameter and on a graph paper plot dm square versus m, where m is the order number, this graph, and it should be a straight line not passing through the origin, and from there find out the dm square values for any two unobserved points and then calculate the wavelength using the formula given, where r will be supplied. In our case the value of radius of curvature is 60 centimeter. So that's all. Thank you.